Hello my dear students, today we are going to discuss about the current electricity. In electrostat, we study about the charge in rest condition and properties associated with charge in rest condition. But in current electricity, we are going to discuss about the charge in motion condition. Okay, so our chapter is chapter number 3rd, that is current electricity. Okay, so in this chapter, we study about the charge in electrostat. We study we study about charge in rest condition. Okay, and in current electricity and in this chapter we study about charge in motion condition. In motion condition. Okay, तो charge means क्या है? In rest condition we study about the charge. ठीक है, means in we consider a chapter that is electrostats. Okay, and in current electricity we study about the charge in motion condition. What is the basically current? So first we are going to discuss about the current. What is the current? The rate of flow of charge, the rate of flow of charge through a cross section is called current electricity. Okay, the rate of flow of charge through a cross section, that is called current electricity, means that is called current, not current electricity, that is called current, means I is equals to delta Q upon delta T. Okay, this is the current. So what is the current? The rate of flow of charge through a cross section is called electric current. Now there are two types of current. First is alternating current and second one is direct current. So first of all, there are two types of current. There are two types of current. First one is alternating current. And second one is direct current. Okay, what is alternating current and what is direct current? When the magnitude of current is changing continuously and direction changes periodically, then the current is called alternating current. Means whose magnitude continuously varying and the direction varying periodically, then the current is called alternating current. So firstly we are going to discuss about the AC alternating current. Suppose we have got a time axis and here we consider a current, so whose magnitude changes continuously and direction changes periodically, then the current is called alternating current. Okay, and what is DC? In AC, we separately discuss in chapter number 7 according to our NCRT. Okay, in this chapter we will discuss about the DC only. So what is the direct current whose magnitude is continuously constant with respect to time, that is called your direct current. So one is your alternating current whose magnitude continuously changing with respect to time and direction changes periodically, that is called your alternating current. Another one is direct current whose magnitude continuously constant with respect to time, so that is called your direct current. Okay, now we are going to discuss about the first. In DC we are going to discuss about average electric current. Average electric current. What is average electric current? So what is average electric current? If delta Q charge is flowing in time interval delta T, then the current is called your average electric current. So I average is delta Q upon में delta T. If delta Q charge is flowing in time interval delta T, if delta Q charge is flowing in time interval delta T, then current is called average electric current. Okay, now second one is our instantaneous current. Instantaneous current. What is instantaneous current? If we find the value of current at a particular instant, then the current is called instantaneous current. Means value of current at a particular instant, that is called your instantaneous current. If the value of current at a particular, the value of current at a particular instant the value of current at a particular instant is called instantaneous current. Okay, so it is a one part of average electric current. In average electric current, when delta T tends to 0, then we consider here instantaneous current. So I instantaneous means dq upon dt. In average current, when delta T tends to 0, then particular instant we consider her instantaneous current, that is called I instantaneous dq by dt. Okay, so now we are going to discuss about some important points related to current. So first one is the direction of current is always in the direction of positive charge and opposite to the direction of negative charge. The direction of current is in the direction of positive charge and in the opposite direction of negative charge. So in the positive charge, current always flow in the direction of positive charge and opposite to the negative direction of charge. Second one is current is a we consider current is a conventional current because it has both magnitude and direction, but it has both magnitude and direction, but it does not it does not follow vector algebra vector algebra rules like dot and dot product and cross product. Means current has magnitude also, direction also, but it is considered as a conventional current because it does not follow vector algebra rules, means dot product and cross product. Suppose the 3 ampere of current is coming to the at point, and here 2 ampere current is passing from this line and 1 ampere current is passing from this line, and here angle is 30, 45, 50. There is no defect, there is no effect of this angle on the current. Incoming current equals to outgoing current. So that's why we consider current as a conventional current. Okay, as a scalar we can use it. So we are going to discuss about the numericals on this topic. First one, suppose we have given a conductor and there is a cross section, and in this cross section 10 proton per second flowing in the right direction and 2 electron per second flowing also in the right direction. Then we have to find the value of current through this rocks, through this cross section. So we have to find the value of current from this cross section. So we know that the direction of current is always in the direction of positive charge and opposite to the direction of negative charge. So the net current is I1 plus I2. We are considering this current I1 plus I2, and we are taking I1 current due to 10 proton per second. So direction of current is always in the direction of positive charge, and positive charge is moving in the right direction. So we are considering current I1 is also in the right direction, and I2 due to 2 electron per second, and electron are also moving in the right direction. So electron moving in the right direction, the direction of current due to these electrons are in opposite direction. So that's why we are considering to the left side. So net current I1, that is 10 proton per second in the right direction, and we are considering right direction as a positive and left direction to the, for our sign convention, we are considering right direction as a positive and left direction to the negative for our convention. So here 10 proton per second in right direction, so that's why we are considering positive, and 2 electron per second also in the right direction, but direction of current due to these electrons are in opposite, that's why we are considering negative. So here 2 electron per second, and we know the charge on proton, magnitude of charge on proton and electron is 1.6 into 10 to the power minus 19 coulomb. So net current 10 minus 2, 8 electron per second, and electron per second, that is net current is 8 ampere. And here the sign is positive, means the direction of net current is in the right side. Okay. Same type we are considering a second numerical. In this situation we have given one electron is revolving in a circular path of radius capital R. One electron is moving with velocity v on a circular path of radius R. Then we have to find the value of current. Find value of current. Suppose we are considering at point P, find value of current at point P. So we have to find value of current at point P. So we know that the value of current I is equals to dq upon dt. The value of current I equals to dq upon dt, and here the charge is electron, and we have to find the time when the electron come again from this cross section area. So we know time equals to distance upon speed, and distance is circumference of the circle. So we are taking 2 pi r and speed is v. So we are putting this value here, 2 pi r upon v. So current is av upon में 2 pi r. So this is the value of current. In the same situation, if we have given the linear velocity is replaced by the angular velocity omega, then we know the relation v equals to r omega. So here we know v by r equals to omega. So the value of current in this situation I equals to e upon v by r, we consider omega. This value v by omega is v by r is considered e omega upon 2 pi. So this is the value of current in this situation. Let us take one more condition. If q is equals to 2t square plus 4t plus 5, then find current, then find average current at t is equals to 0 to t is equals to 5 seconds. We have to find the value of average current, and second one we have to find I, instantaneous current. Okay, so for first part, average current, we know I average is equals to delta Q by delta T. We are taking average current is delta Q by delta T, means we can write Q2 minus Q1, T2 minus T1. Okay, we are taking Q2 minus Q1 delta Q and T2 minus T1 delta T. Okay, so here the value of Q is at 5 seconds. So we are considering at 5 seconds. So Q2 2, we are putting the value at 5 where the in place of T. So we get the values so Q2 equals to 50, 20 and 5. So we get Q2 is 75 coulomb, and same at 0 at t equals to 0 second. So put the value of where the place t, we put the value of 0. So we get Q1 equals to 5 coulomb. So we get 75 coulomb at Q2 and 5 coulomb at Q1. So put 75 coulomb here and 5 coulomb here, and T2 minus T1. T2 is 5 second and T1 is 0. 70 by 5. So average current is 14 ampere. So in this way we find the value of average current. Same here, we have to find the value of instantaneous current. So for instantaneous current, we know the formula is dq upon dt. If the time interval is very small, then we consider dq upon dt, and by integrating this value with respect to time, so we get the expression 2t square plus 4t plus 5. So we are going to differentiate. So 2t square become 2t, 4 bahar, constant t we get 1, and constant we know the value of constant differentiation is 0. So from here we get 4t plus 4, and we have to find the value of current at a particular instant. So we consider here t equals to 2 second. Suppose we have to find the value of instantaneous value of current at particular instant, means t equals to 2 second. So put t equals to 2 here. So we get 12 ampere. So this is the part of current electricity first lecture. Thank you for watching.